Okay, this is going to be part 3 of section 10.2 on polar equations. This should be a little bit shorter than the other two. Again, a lot in this section. If you remember what we've done so far, I've kind of gone through and shown you all of these graphs. These are really the ones that you're going to need to know. So hopefully you're writing these things down. Okay, there are two others. R equals secant theta and R equals cosecant theta. Okay. Again, if we just look at my graph, easiest way to do this, again, we don't have a secant key, right? So what do we graph? 1 divided by cosine theta. Okay. I'm going to set up my window. So I'm going from 0 to 2 pi. Okay, my theta step is just some small decimal. That's automatic in there. Okay, I have x minimum -5 to 5, x maximum -5 to 5. It doesn't matter. You know what? Let's just hit zoom 6 anyways to give me a standard window. And what do I get? I get a vertical line going through 1. Okay, so in general, the graph of r secant theta is a vertical line. Okay. Which should make sense because if you remember, the cosine is related to the x-coordinate, right? So vertical lines are in the form x equals. So in this case, it's x equals 1. Okay. Being the young mathematicians that you are, I think it's going to be pretty obvious what happens when we do cosecant. This is 1 over the sine of x. Zoom 6. And here we get a horizontal line. Okay. And that goes through the point y equals 1. So that is just going to be a horizontal line through that. I don't think I did this one up here. This just goes like that. Okay. So add to my list, r equals secant theta is a vertical line. R equals cosecant theta is a horizontal line. Okay. So when you're going to do this next test, I would have this sheet out so you can look at these different lines and figure out whether or not we're going to graph them or whether or not we're going to look at a graph and try to come up with an equation. Let me show you what I mean by that. Okay. This next section, okay, example 13 says find the equation of this graph. Okay. Well, what is this? This is a lemma with no inner loop. Okay. So this is a lemma with no inner loop. So it's one of these. It's going to be in the form a plus b sine theta. Okay. Which they told me. Okay. And I know that a is going to be larger than b. All right. So this graph is what? Symmetric to the x-axis. Okay. So which equation has symmetry to that axis? That was the cosine. Okay. So I know that this is r equals a plus b cosine theta. Okay. So what are 2 points? Okay. Here's a point. What are the coordinates of that point? The angle is 0 and the radius is 9. So I guess that would be 9, 0, r comma theta. How about this one? What's the angle? Pi over 2. So the radius is 5. The angle is pi over 2. So plugging those points into this, r is 9 when the cosine is 0. What's the cosine of 0? 1. So 9 equals a plus b. What is this? 5 equals a plus, what's the cosine of pi over 2? Well, the cosine of pi over 2 is 0. So this is just a plus 0. So right away I know a equals 5. How do I find b? I plug it in. 9 equals 5 plus b. Subtract 5. b equals 4. So my equation is r equals 5 plus 4 cosine theta. Okay. All right. How about equation 14? Find an equation of form r equals a plus b cosine or a plus b sine. And here I have this inner loop. So a has to be less than b. Okay, so I got this inner loop again. But now it's symmetric to the y-axis. So that was my sine function. So I know it's going to be this. Find some points. What is that point? That radius is 2 when the angle is 0. What is this? That radius is 5 when the angle is pi over 2. Okay, so if I know I'm using sine, what do I get? 2 equals a plus, what's the sine of 0? It's 0. So a equals 2. What's the other one? 5 equals a plus b. What's the sine of 1/2? Or pi over 2? It's 1. So 5 equals a plus b, but I know a is 2, so b must equal 3. So without too much difficulty, okay, I get an inner loop, okay, where a is less than b. So everything seems to be making sense, at least to me. I don't know about you guys. Hopefully we're starting to. But again, with these polar equations, being able to pick points off of a graph is going to be pretty important. Okay, so make sure you're understanding where I'm getting these points. You know, if I want to get this point, okay, it looks like my radius is 1, but how did I get up there? I already used pi over 2 here, so that was probably 3 pi over 2. And a radius of -1. So I went down here and then the opposite direction. So I went all the way around here and then back up into there. Okay, so be careful with that. All right. All right. I guess I could have put that in the other video. So make sure we know how to graph points. Make sure you write those down. So I'm going to leave that up. If you haven't already done so, you need to have all of these equations. Okay? So I will try to also put that in my notes and get that up in Blackboard. But try to have those written down so you know what these things are. All right, good luck.